Every year, the volume and velocity of global academic publishing compound, creating a massive archive of human inquiry. To understand where science is heading, we have to look past the individual abstracts and start analyzing the metadata. This is the Proceedings of the International Conference on Research in Education and Science. Published in May 2023, this volume contains 186 articles, all vetted through a double-blind peer review process. We are not going to comb through the specific methodologies of these 186 papers. Instead, we are going to extract their titles and treat them as raw data points. Extracting this metadata allows us to build a topographical map of global academic focus areas, clustering similar topics to reveal structural patterns. A table of contents provides a verifiable map of exactly where human attention, institutional funding, and technological innovation are currently directed. Historically, advanced technologies like neural networks and virtual reality were often confined to computer science and engineering departments. The 2023 data suggests a shift toward the horizontal integration of these frontier technologies into traditional legacy disciplines. Non-computer scientists are adopting complex computational architectures to solve highly localized, domain-specific problems. This shift alters the nature of the research pipeline, moving from reactive problem-solving to proactive, data-driven optimization. Technology has become the invisible infrastructure required to conduct all other research. The first data cluster pulled from the proceedings involves the application of spatial computing, specifically VR and AR. One data point is titled Virtual Reality Trainers for Students with Disability. A related title follows, Exploring Learning Disability Students' Experiences in Using AR Technology in Physical Education. Connecting these reveals VR and AR are researched to map motor performance and aid disabled youth. Legacy educational models relied on physical interventions, which were often harder to measure and standardize with precision. This research highlights how VR provides safe, infinitely repeatable, and quantitatively measurable environments for physical education. Spatial computing has evolved into a validated clinical tool, redefining how researchers approach physical accessibility in education. A more complex technological vector dominating the data is the use of convolutional neural networks, or CNNs. We can isolate the first CNN data point, a brain tumor cancer detection using hybrid convolutional neural network. Now look at a seemingly unrelated data point, recognition and detection of traffic signs using convolutional neural network. These fields are starkly different, moving from oncology to urban traffic management. A third node regarding machine learning for financial management shows the spread into economics. The barrier to entry for utilizing complex AI architectures has lowered significantly. Advanced computational models are quickly becoming baseline utilities, allowing domain experts in many diverse fields to seamlessly deploy them. Geopolitical and environmental stressors are also forcing rapid technological adaptation within this research data. One specific title stands out, Moodle System for Preparation Surgery Medical Students During the War. This virtualizes high-stakes surgery training due to active conflict. This connects to environmental crisis adaptation, seen in the paper on IoT-driven sustainable green energy systems. Both fields rely on remote digital infrastructure to stabilize critical physical systems that are under duress. This research documents the design of optimized, crisis-resilient frameworks. The digitization of education and infrastructure is increasingly driven by the necessity of ensuring continuity in extreme, unpredictable environments. The most recent technological wave visible in the proceedings is the rise of large language models and generative AI. One exploratory paper asks whether ChatGPT can facilitate personal learning environments, noting the focus on benefits and risks. This exploratory work is paired with a regulatory response in the title, Artificial Intelligence and Business Ethics. Academia is simultaneously testing the limits of LLMs while attempting to build ethical frameworks to contain them. This shift forces professors to design curriculums that account for students outsourcing aspects of their cognition to machines. The integration of AI is forcing the academic establishment to rethink what constitutes original thought, ethical research, and human learning. Pulling back to view the entire macroscopic dataset, we can see all 186 articles mapped out. The density of the overlap between technology clusters and traditional pedagogy or science clusters shows significant cross-pollination. This map suggests a trend where isolated, single-discipline research is increasingly giving way to hybrid models. Examples include utilizing gamification to teach biochemistry or building virtual zero-waste simulators for agriculture. To solve localized physical problems, modern researchers are frequently deploying globalized digital architectures. This represents a discernible shift in how academic research is baseline structured. Fluency in these digital toolsets, specifically AI, VR, and IoT, appears increasingly central to advancing academic research across these diverse fields.